Okay, so let's start today's lesson by finishing that homework. So we have this graphing worksheet that we needed to do. So the first thing it asks me to do is to, first I'm going to start with number 1. Oh, I know, I don't need that. There's putting that in there. Thank you, though. All right, graph the points A, B, P, and Q. So I'm going to go ahead and make myself an XY axis. This is my X. This is my Y. And if I were to graph the point A, it's at 1, 1, so that's here. And B is at 5, 1, 1, 2, 3, 4, 5, 1. And P is at 3, 4, 1, 2, 3, 1, 2, 3, 4. And Q is at 3, negative 1. 1, 2, 3, 1, 2, 1, 2, 3, negative 1. Almost messed up there. Alright, first it tells me to find the midpoint of AB. Well, first we've got to make AB. So segment AB is right here. So my midpoint of AB can just be found by just counting, right? 1, 2, 1, 2. Can I scoop it up or zoom in? Yes, I can. There we go. All right, so here's my midpoint of AB. Call that M. It asked me a question, so I'm going to say, okay, for question number 1A, my midpoint is 1, 2, 3, 1. 3, 1. Now it asks me to draw a perpendicular bisector. Well, AB is my only line segment, so the perpendicular bisector would be something that is going, this is a slope of 0, so it means my other slope is going to be an undefined slope, right? I'm going to go ahead and draw my perpendicular bisector. You didn't have to construct it, it just said to draw it, right? Draw a perpendicular bisector. If you said construct, then you'd have to have constructions on there, okay? All right, find the measures of PA, PB, QA, and QB. So here's my PB and my PA, my QA, and my QB. All right, so let's find PA first. This would be 1C. So PA is equal to, here's PA. Well, my rise is 1, 2, 3, and my run is 2. So it would be 3 squared plus 2 squared. You guys should all be familiar with that, right? We've been doing that for months. So 9 plus 4 is the square root of 13. PB, see what PB is. PB is on this side. This would be rise 1, 2, 3, run 2. So the same, right? So this one is the same as that one. QA. QA is right here, so that's a rise of 2 and a run of 2. So 2 squared plus 2 squared is square root of 8, correct? And QB. QB is right here, up 2 over 2. So 2 squared plus 2 squared equals the square root of 8. And you should have predicted that from the beginning because we've already seen this picture before, right? This is the perpendicular bisector theorem picture that we used when we were putting all the pictures and the, what would you call it, explanation picture, explanation, and then the definition or theorem. think I have it right here. I'm not going to go through it. Okay, finally it says make a conjecture based on your finding. Okay, so D, my conjecture would be what we've already found, right? Any point on the perpendicular bisector is what? Any point on the perpendicular bisector is going to end up being equidistant. Very good. Equidistant from what? From the end point. That's what we were proving right here, right? That no matter what points I put on here, it's always going to be the same distance to the end point. All right, guys, need that for just a quick second? All right, let me go ahead and pause my recording. You willing? All right, let's do number 2. All right, so number 2, graph and connect the points A, B, and C. So do you see where you should have at least had A, B, and C, like you're all capable of doing that, right? All right, so I'm going to make myself another graph. I feel really sorry for period 6 for the people who didn't do their homework. Can you imagine if I am like I am right now by the time I get to them? Okay. So it says graph and connect the points 1, 4. So 1, 1, 2, 3, 4. That's A. B is -3, -4, -3, -4. And C is 4, 1. 1, 2, 3, 4, 1. It said over 1 up 4. A is 1, 4. B is -3, -4. Did I do something wrong?
No, yeah.
Okay. Oh yeah, I did. Uh-oh. B is -3, -4. I did -3, -3. Good thing we looked at that. Thank you for 1. Okay, so draw and connect those points. Again, I'm just going to say it one more time. If you did not do that, you did not try. Correct?
Okay.
Okay. Find K if CK is a median of triangle ABC. Remind me what a median is. It's the middle of a side from a vertex to that side, right? So if it's talking about find K is CK, well, if this is C and I don't have a K, right, and if CK is going to be the median, well, would CK be here? Would CK be here? Or would CK be here? The last one, right? Remember we did that on our foldable? Okay, well, can I find the middle by just going this way? Let's see. That's over 1 down to, over 1 down to, over 1 down to, over 1 down to. Ooh, I could even count it, right? So if I go up 2 over 1, up 2 over 1, is that the same as up 2 over 1, up 2 over 1? You wouldn't even have to use midpoint formula for this one, right? You just count slope. So K is right there. It said find K. So 2A is find K. K is at -1, 0. I'm going to go ahead and draw that. There's CK. Then it says find the slope of the perpendicular bisector of AB. Well, we already found where AB bisects, right? It bisects right there. So we need a perpendicular bisector. Well, in order to do a perpendicular bisector, I can't eyeball it. I mean, I guess I could use my, I guess I could do this, because that's a 90-degree angle right there. That would work, right? If you didn't know that, you could count slope. If AB, the slope of AB is up 2 over 1, what's the slope going to be of the perpendicular bisector? I'm going to say that again. If AB, the slope is up 2 over 1, then what would the perpendicular slope of that be? Negative 1 over 2. Correct? So I could go up 1 over 2, and that would give me my perpendicular bisector. I'm just putting it, everything we've done, I'm putting it all together, right? Haven't we done that? Haven't we done doing the median? We did that yesterday. Haven't we done all of this, finding the length of sides? It's like a big review activity is what it was, with a little extra. Okay. So, do we have any questions to answer? What is the slope of the altitude containing vertex C? Ooh, altitude. What's the altitude containing C? Well, altitude means what? What do we find out about altitude? It makes a right angle. So if I were to kind of turn my paper, because containing C means it's got to contain C right here. So the altitude would be right here. So let's make a 90-degree. See how I'm using this? What? Do you guys see that I'm using this line? And I'm going to line it up here, and I'm going to slide it over and make myself an altitude. Can I find the slope of that altitude? Let me turn my graph around. You don't have what? Oh, gotcha. Well, what I did, I'll tell you right now. If I go here, doesn't that cross right there? So up 1 over 2. Up 1 over 2. That made my altitude. You got it? So the slope would be up 1 over 2. And that is 2c. And it's actually going in the negative direction. What else can I say about this? They talked about this perpendicular bisector. They also talked about this altitude. What did I discover about both of these? They have the same slope. If they have the same slope, what could I say about them? They're parallel, right? Stop making connections. All right, how many of you need a second to finish this up? Okay, I'll give you about 3 seconds. All right, let's do number 3. Number 3 says graph and connect the points. Okay, so we need another graph. All right, so graph and connect the points of D, which is at 1, 1, 2, 3, 4, 5. That's D. And E is 1, 2, 3, down 1, 2, 3, 4, 5. And F is negative 1, 2, 3, 4, negative 1. Negative 4, negative 1. So draw, graph them, and connect them. D, E, F. You poor things that try to do this all on one graph. I'm so sorry for you. You're probably just like, what is going on? Alright. So first ask me to draw the perpendicular bisectors. How can I make perpendicular bisectors? How did we make them? Yeah, we pinched them. Right? So I would have to pinch these, or I can use a compass, right? How many of you used a compass of the ones that actually did their homework? Good job. Okay, so perpendicular bisector. So if I want to bisect this one, I would want to go a little bit over half. Oh, wait a second. There's an easier way. To do it a different way other than I can't believe I was going to do this right now and make all kinds of marks on my paper. How could I make a perpendicular bisector of this line? Count it. So if the slope of this is the slope of FE, count the slope. Up 1, 2, what is the slope? 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7. Up 4 over 7 in the negative direction. So what would the perpendicular slope be? 7 over 4. And then I've got to find the middle of it. Shoot, this is pretty hard. That means I've got to find midpoint formula. So maybe it is easier. I think it's easier to do this. Alright, so I go a little bit more than half, and I'm going to make a mark here and here. And I'm going to go the other side with the same measurement, compass on the same setting, and make the same arc. There's one. Is this one, gosh, where can we judge it from here? Is this up 7, 4? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. It looks like it's going that direction. Right, I did pretty good. There's EF. I'm going to do DE. Oh, DE looks like it's right there. Let's count. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Up 5 over 1. Midpoint then is right there. This one's easier. So then what's my perpendicular? Not up 5 over 1, but up 1 over 5. Well, should have been up 5 over negative 1. So up 1 over positive 5. 1, 2, 3, 4, 5. There it is there. How's this? You know, you guys know I don't use the document camera very often. Am I doing okay?
Yeah.
Okay. See, this is just too messy for me. Okay. Now what? This one. Can I find the midpoint on this one? Not very easily, right? So maybe we should just draw this one? Okay. So, I'll just use the same setting as I did last time. So there's one arc. Here's another arc. Go to the other endpoint. There's an arc. And there's an arc. You see it? There's another perpendicular bisector. Alright, now what do you want me to do with it? Let's see. Using a compass, draw a circle, using the circumcenter and one of the vertices. Oh, it says label the circumcenter. Well, if I just had all of my perpendicular bisectors join, like we did in class, what do you think this is called? I'm gonna go out on a limb here and say that it's, on a limb, sorry, And so it's the circumcenter, right? It's probably called the circumcenter. All right, so I label the circumcenter, and using a compass, I'm going to draw a circle using the circumcenter and one of the vertices. Ooh, this sounds like fun. So I'm going to use the circumcenter and one of the vertices. I'm going to see what happens. That's pretty freaking cool. Would you not agree? Mm-hmm. What happened? The circle hits on all three of the vertices. Yes, ma'am. For the first one here, I use my compass. I just made a perpendicular bisector using my arc mark. Remember, if we want to have a perpendicular bisector, if I want to construct it, I just take my compass on my end point and I go more than halfway, and I make an arc up above and one below, and then I go back with the same setting. I don't move the setting, and on the other end point, and make an arc, and that makes a perpendicular bisector. All right, so what can we say about this? What can you say about the distance from the circumcenter to each one of the vertices? They're all equal, right? So this one, that distance is the same as that distance, is the same as that distance. You could actually take this triangle, it'd be pretty cool, and you could spin it around inside of that circle. Okay, that's number 3. Oh, we need to write, actually, 3D is, what can you say about the distance? The distances are equal. All right, ready for number 4? All right, let's do number 4. All right, it says graph and connect the points. You know what I'm going to do? I think I'm going to leave number 4 and 5 as homework. How about we finish up our foldable? And let's go ahead and finish up our foldable, and then if we have time at the end of class, we'll come back to this. Okay? All right, so you should have your foldable out. It looks like this. We finished this yesterday and glued it together. Let's summarize the altitude. All right, so the altitude is the shortest distance. First of all, an altitude always makes, let's start here. I have a feeling that my Moby is not going to cooperate with me. Yeah, let's try another pen. It was the pen. Okay. First of all, altitudes make 90-degree angles. .90-degree angle. So this makes 90 degrees, and this makes 90 degrees, and this makes 90 degrees. All right, what else can we say?
Can you write that?
Yes. Remember we talked about how the fact that if I were to take this line and if I were to swing it out, I'd have to like extend it, like if I had a piece of string, and I tried to like find the distance from here to here, the string would have to be longer. So that makes the altitude the shortest distance. I'm not going to be able to record this anymore. My pen's not working. I'm going to have to go to the board. The shortest distance from the vertex to the opposite side. That's perfect, though, because then my recording, at least I recorded part of the homework for anybody who's absent. Okay, so bye-bye to anybody who's listening.